A lot of the rules we see expressed about exponents tend to be where you take a binomial and you square it. So you square the first, square the second, and add double of the two terms multiplied. Another famous rule of exponents is if I have a squared b to the fourth and I cube all of that, I just distribute that exponent across the other exponents and I multiply those. Another but lesser discussed rule is supposing that I had fractional exponents and I do the same kind of application. I multiply the 4 by the 1/2 here, and so I just get a to the 2, b to the 4/3. But there's a lesser known combination of these, where you have fractional exponents creating a binomial, and then you square it. So exactly as we did at the beginning, where we are just squaring the first term and squaring the second term, and then doubling the two terms multiplied, we do the same thing. But this time it has fractional exponents. So if I were to pick slightly different coefficients and slightly different exponents here, where I have a to the 1/3, but then I'm minusing b to the 1/4, and I square that, this becomes a to the 2/3. The end term is a positive b to the 1/2. And the middle term is still double, but it's doubling a negative. So I have a negative 2 times a to the 1/3, b to the 1/4. I've not really seen any videos in particular on this exact demonstration, so hopefully this is helpful. Here's another way this might show up, and that's where if the exponent is greater than 2. So let's say we have x to the 1/4 minus y to the 1/3, and I'm cubing it. If you remember Pascal's triangle, that's great. You know 1, 3, 3, 1 are all of your coefficients. Or you could go ahead and multiply these terms out. In which case, this would be the hardest part of doing any of this problem, which would basically just be take the last two factors, the x to the 1/4 minus y to the 1/3, and multiply it by the last x to the 1/4 minus y to the 1/3. Once you get your x to the 1/2 minus 2x to the 1/4 y to the 1/3 plus y to the 2/3, well, now you just have to multiply the first factor through. And so when we multiply this through, we now have all of these terms to have to combine. So if I go ahead and just combine these columns of these terms, that gives me 1x to the 3/4 minus a total of 3x to the 1/2 and y to the 1/3 plus 3x to the 1/4 y to the 2/3, and then minus 1y. And you can see the 1, 3, 3, 1 here, which you would have gotten from Pascal's triangle. So those are some of these problems that are less common, and I haven't really seen too much information out there on how to solve them, so hopefully this was helpful to you.